Good afternoon, class. We are looking at Chapter 5, Integrals, and here's Section 5.4, the Substitution Rule, Part 1. We covered 5.1 to 5.3, the Fundamental Theorem of Calculus, or FTC, and now we're going to go to the Substitution Rule. We have many integration formulas for you here. And here's the FTC. There are two of them. One of them says if you take the integral of f of t dt from a to x and then differentiate it with respect to x, you get f of x as the answer, which means differentiation will undo the integration. They are reverse process. And if you say capital F prime and lowercase f are the same, the integral of a to b f of x dx, which is a definite integral, which is a number, becomes capital F of b minus f of a. And now we have the substitution rule. The integral of f of g of x times g prime of x dx, where g of x is u, g prime of x dx is du, is f of u du. And so 5.4, the substitution rule. Integration by substitution is the reverse process of the chain rule in differentiation. So for example, if I want to differentiate capital F of g of x, I get capital F prime of g of x times g prime of x. So d dx of capital F of g of x is f prime of g of x times g prime of x. Capital F prime, we represent it with lowercase f, so f of g of x times g prime of x. Now, if we let g of x be represented by u, then du dx, the derivative of that is g prime of x, and du is g prime of x dx. So the integral of f of u du, which is capital F of u plus c, or capital F of g of x plus c, and here's the synopsis of what we just did. Over any interval for which u equals g of x is continuously differentiable and lowercase f is continuous on the range of this function, the following relationship holds. The integral of f of g of x, g prime of x dx, where g of x is u, g prime of x dx is du, we will say is the integral of f of u du, capital F is equal to capital F of u plus c, or equals capital F of g of x plus c. This is known as the substitution rule. So, as an example, we want to integrate the integral of 2x, parentheses x squared plus 5, quantity cubed dx. The tip is look for a function u equals g of x anywhere in the integrand, and its derivative du, or g prime of x multiplied by dx. First and foremost, one may say, okay, it's not a big deal. I can raise this to the power of 3 multiplied by 2x and do the math, and you're right. But what if we had, instead of number 3, let's say we had number 30? Then it would make it very difficult. That's why we want to go with the substitution method. So we are dealing with polynomials here. And in that case, the one that is more complicated is a choice of u. So if you choose x squared plus 5 to be u, you know that du dx, therefore, is simply 2x, and therefore du is 2x dx. To make sure we know what we are doing, we are going to move the 2x next to dx, so it becomes absolutely clear that we have u cubed times du. And now we can use the power rule on that. This is 1/4 u to the power of 4 plus a constant. Reverse the substitution. Instead of u, we're going to put x squared plus 5, and we get 1/4 x squared plus 5 to the power of 4 plus a constant, which is the final answer. Now, if you were to check, all you have to do, differentiate this. You get this one without the dx, without the dx. That's how you check it, everybody. Same thing here. We are dealing with a bunch of polynomials. The more complicated one is the choice of u. And you should notice that if you were to differentiate this, you get 3x squared. Therefore, note that 3x squared is the derivative of x cubed plus 1. And let's move things around. Let's put 3x squared next to dx. Now, if you choose u to be x cubed plus 1, its derivative is 3x squared. Therefore, du is 3x squared dx. So the integral becomes the integral of u to the power of 10 du, and that is a simple case of a power rule. 1 over 11 u to the power of 11 plus a constant, or u to the power of 11 divided by 11. It's the same thing. You can write it in this fashion, or you could write it in this format. Makes no difference. Now, reversing the substitution, meaning u now is x cubed plus 1. We get x cubed plus 1 to the power of 11 divided by 11 plus c as the final answer. And as always, if you differentiate the result, you should get this one without the dx. Okay, without the dx. Again, you can multiply, but going by substitution method, the more complicated polynomial, in this case, x squared plus 3x plus 5 is a choice of u. You notice the derivative is 2x plus 3. Therefore, du is 2x plus 3 times dx. So this number 9, whether you have it inside the integral sign or outside makes no difference. It's a multiplier, it's a coefficient, it will remain. So this is u, this is du, and the integral of u follows the power rule. This gives you half of u squared. So it becomes 9 halves u squared and a constant. Replace the u, 9 halves, x squared plus 3x plus 5 quantity squared plus c is the final answer, everybody. When we look at these two examples side by side, we notice both are fractional format. Of course, this is a rational function. A rational function, by definition, the top and the bottom are both polynomials. This is not transcendental function in essence as far as the name. But the methodology is the same. Number one, any fraction, can I simplify a fraction? Can I put it in its lowest term? That's the first question you ask. And if the answer is no, for integration, normally the denominator is a choice of u. If you were to take the derivative, du dt becomes e to the power of t, and therefore du is e to the power of t dt. Now, it is important for everybody to know dt, dx, it's always part of the numerator. It's never, ever a part of the denominator. So let's put it next to that. And the reason I do that, I want to make sure for everybody to see we have du in the numerator and u in the denominator. And so what we are looking at here is similar to the integral of 1 over x dx. So we have a natural log as the answer. So ln of absolute value of u plus a constant. Replace the u. We are done. Since 5 plus e to the power of t is positive, you can put the parentheses. Also, if you differentiate the result, you get the same thing without the dt. And we are done with this question. This is similar. The very first question, can I simplify it? The answer is no. If you look at the denominator, a is 1, b is 2, c is -1. And as you recall, b squared minus 4ac is called the discriminant. So 2 squared minus 4 times 1 times -1 is positive 8. A quadratic expression can be factored that its discriminant is a perfect square, like 2, 1, 4, 16, 100, you name it. So it can't be factored. By the way, even if you could factor, it should have a factor of x plus 1, otherwise it can't be simplified. So we choose the denominator as the choice of u. And notice if I differentiate that, everybody, I get 2x plus 2, which is 2 times x plus 1. And therefore du is 2 times x plus 1 dx. Now, I'm going to put the dx at top again because I want you to see this. And in your book and many books, what they do, and if you've seen it before, I want to show you a different method. In many books, they solve for dx. I give you an easier way. Anytime a number, a multiplier, a coefficient is here, and this one doesn't have it, it just put it in. So if I throw in number 2, how do I undo that? I multiply by its reciprocal, which is 1/2. You can only do that to numbers. So in other words, if x is missing, you can't do that, okay? Has to be a number and number only. If 5 is missing, put 5 and 1/5. 10 is missing, 10 and 1/10. 2/3, put 2/3 and 3/2. Their product must become 1. Now the numerator, as you can see, is du, the bottom is u, and this part looks like this part if you ignore the 1/2. So you get this one, and of course 1/2 in front, and you replace the u, and you're done. Now, as always, if you differentiate, you get the same thing without the dx. Also, in this case, if you lose the absolute value, is okay because it's positive. In this case, it's not, because this expression could be positive, could be negative. Now, I want to add one more thing because it makes it interesting when it is a fractional format. So if I write the reciprocal of part A, take a look, the reciprocal of part A. In part A, I have to use the substitution method. If I write the reciprocal of that or reciprocal of that, first I have to divide and simplify. And in this case, when I do this one, I get 5e to the power minus t. When I do this one, I get 1, and I no longer need to use substitution method because this, you divide by -1 becomes minus 5e to the power minus t. This one becomes t, and a constant, you're done. No need for substitution. Extremely important that you see these questions side by side, everybody. Side by side. We need substitution. We need substitution. There is no need for substitution. We want to integrate, and we are integrating 5x to the power of 4e to the power of x to the power of 5 dx. Anytime you're dealing with an exponential format and you're integrating, the exponent normally is a choice of you. You know the derivative is 5x to the power of 4. Therefore, du dx is 5x to the power of 4, and du is 5x to the power of 4 dx. To make it clear as to what we are dealing with, we're going to move this next to dx. And so this is e to the power of u, and this whole thing, 5x to the power of 4 times dx is du. And you know the derivative of e to the power of u, and the integral of e to the power of u is itself. So it's e to the power of u and a constant. And now u is replaced with x to the power of 5. And if you differentiate the final answer, you get the integrand without the dx, of course. This is the integrand. This is, remember, the dummy variable. Again, we are dealing with an exponential. So if we choose the exponent, x to the power of 5 minus 2 as the choice of u, its derivative is 5x to the power of 4, and du is identical to this, 5x to the power of 4 dx, because negative 2, the derivative is 0 since it's a constant. We're going to do the same thing. We are going to move x to the power of 4 next to dx so it becomes clear as to what we are dealing with. We notice 5 is missing. Again, you can solve for dx and move on. But a better and easier way is, well, a number is missing. So if I put in a number, that means I'm multiplying by 5. How do I undo that? I divide by 5. It's reciprocal. So when I put the 5 in, I'm multiplying by. So I have to divide by or multiply by its reciprocal. Now I'm dealing with e to the power of u du here. So this portion is the same as this one, which has the same answer, but keep the 1/5 and replace the u. And the final answer is 1/5 e to the power of x to the power of 5 minus 2 plus c. If you differentiate the final answer, you get this one without the dx, and that shows that you have the correct answer.